Hi everyone. In this session our discussion topic is spectrum. What is spectrum and types of spectrum, and what is the minimum terminology required for the studying the spectrum. The terminology which is required is electromagnetic radiation, and what is called VIBGR, and what is called transmitted radiation. Electromagnetic radiation, very simple, nothing but light. Light is a combination of electric and magnetic field. They are propagated perpendicular to each other and they are also perpendicular to their path. That is called electromagnetic radiation. Simply, light is electromagnetic radiation, or electromagnetic radiation is light. What is called VIBGR? VIBGR, the visible light, that means what is who are present under the light, that is called white light or VIBGR. It is made up of violet, indigo, blue, green, yellow, orange, red. That is called VIBGR. And then what is called transmitted radiation? Very simple, students. It is a source of light. For example, it is a source of light. This light is falling on a substance. Suppose some of the light is absorbed, some is reflected, and the remaining part of the light passing through the substance, that can be considered as transmitted radiation. This is the source of light. It falls on a substance. Some of the light is absorbed and some is reflected, and some radiation is transmitted from the substance, passed through the substance. This is called transmitted radiation, right? So electromagnetic radiation, nothing but light. What is called VIBGR? White light is called VIBGR. And transmitted radiation means the radiation which is passing through a substance, that is called transmitted radiation. And what is a spectrum? Come to the what is called a spectrum and how many types of spectrums are there. First, taking the definition for the spectrum. Generally, every light is composed of different combination of wavelengths. If it has only one wavelength, one type of wavelength, that can be considered as monochromatic radiation. But normally every radiation is made up of more than one type of wavelength. The arrangement of those wavelengths either in the increasing order or in the decreasing order of wavelength called as spectrum. The arrangement of different radiations in the increasing order or decreasing order of their wavelength on a photographic plate can be considered as spectrum. I am recalling, generally a non-monochromatic radiation. Non-monochromatic means more than one type of radiation. A non-monochromatic radiation is composed of more than one type of radiation. With the help of the suitable devices, arrangement of all these radiations on a photographic plate with the help either in the increasing order of their wavelength or decreasing order of wavelength is called spectrum. I will explain in detail by taking a photograph. And before to enter into the clear definition for the spectrum, how many types of spectrums are there? To enter into the types of spectrum, first student want to know the spectrum definition perfectly. Suppose I have a white light. White light, already we told that it is a combination of 7 colors, VIBGR. It has a wavelength around 400 nanometers. It has a wavelength around 760 nanometer, 760 nanometer. With the help of prism or with the help of a spectrometer, all these radiation, this white light, made an arrangement to fall on photographic plate, film or photographic plate. photographic plate. Then these radiations will be arranged either in the decreasing order or in the increasing order of their wavelength. Suppose here violet radiation is noticed, automatically followed by indigo, then blue, then green, then yellow, then orange, then red. This arrangement, this appearance of the different radiations either in the increasing order or decreasing order of their wavelength is called as spectrum. Right? It is formed due to the diffraction right. So this arrangement is called as a spectrum. This can be considered as a prism. This is called photographic plate. So, or it may arrange like this: R, O, Y, G, B, I, R, either increasing order or decreasing order, but not a zigzag order. That arrangement of the different radiations either in the increasing order or decreasing order of their wavelength is called as a spectrum. And what are the types of spectrum you have? Spectrums are mainly classified into continuous spectrum, discontinuous spectrum. This is one set, and absorption spectrum and emission spectrum. This is one set, and line spectrum and band spectrum. So in this session we are going to concentrate on what is continuous, discontinuous, and what is absorption and emission spectrum, and what is a line and band spectrum. So this is the brief introduction regarding the spectrum. Spectrum is a arrangement of different spectral lines, different radiations either in the increasing order of their wavelength or decreasing order of wavelength on a photographic plate with the help of a suitable device is called spectrum. Right? Now we are entering into the electromagnetic spectrum. What is called electromagnetic spectrum? Students, already I am introducing the terminology called electromagnetic radiation. What is called electromagnetic radiation? Nothing but light. Light is an electromagnetic radiation. Right? The spectrum which is obtained by the analysis of electromagnetic radiation or spectrum which is obtained by the analysis of light is called as electromagnetic spectrum. That means spectrum given by the light. Simply, spectrum of light is nothing but electromagnetic spectrum. Here look at this. I am taking source of light is sun, because all our energy, all our light is coming from sun. From this sun, light is traveling or radiation is traveling and passed through the spectrometer or passed through the prism, then it will be analyzed into different spectral lines according to their wavelength. Here I am taking the lambda value, wavelength is so small, here I am taking lambda value so large. That means I am going to arrange the all types of spectral lines in the increasing order of their wavelength. Generally, which radiations are visible? Which radiations have the lower wavelength? Gamma, and then X rays, and then UV rays, and then visible rays, and then infrared, and then microwaves, and then radio waves. So this is the classification of different types of radiations available in the light. If you are analyzing the light, we are analyzing the radiation coming out from the sun. It is composed of different radiations: gamma radiation, X radiation, UV radiation, visible radiation, infrared radiation, microwaves, and the radio waves. Right? Now we are concentrating on the visible radiation because it is very important for us all the colors visible in the nature is due to the presence of this visible radiation. Actually, for the convenience only, I am giving a larger priority for the visible radiation in the photographic plate. Larger portion is given when compared with all these parts. Visible radiation is a minute part, but that will not affect our explanation, no issue at all. This visible radiation we are focused to see. Here violet color will be appeared, here indigo color, here is blue color, here green, here yellow, here orange, here is red. So all these colors are VIBGR. VIBGR, this is the obtained from the white light. Combination of all these colors leads to the production of white light. It is visible to the human eye. So it is composed of 7 colors, VIBGR. This is totally electromagnetic spectrum. Here student want to learn what is called electromagnetic spectrum. The spectrum which is obtained by the analysis of the light, and this part is called as the white light. White light analysis gives 7 colors. Here wavelength is around 380 nanometer. Here wavelength is 760 nanometers. Right? And here this spectrum, if you observe this spectrum or this photographic plate, all colors are continuously there without any gap, That's why this spectrum or this electromagnetic spectrum can be considered as continuous spectrum. So this electromagnetic spectrum also given the explanation for the continuous spectrum. A photographic plate with different types of radiations, either in the increasing or decreasing order of their wavelength and without gaps, can be called as continuous spectrum. For this I will support with one more a printed photograph of the continuous spectrum and the electromagnetic spectrum. Watch it. Students, this is a big part of the spectrum and it is very useful for all the NEET aspirants and the IIT JEE mains aspirant, and also more useful for the board exam students. What is called absorption and emission spectrum? So this diagram, this schematic representation may useful for you. Look at this. Here this is the source of light. Especially I am taking it as a source of white light. The source of white light is composed of how many colors? VIBGR, 7 colors. VIBGR. Right? This, from this source of white light, the white light is transmitted, the white light is passed through the prism. Here it undergoes dispersion and all these radiations are arranged in the increasing order or decreasing order of their wavelength. For the convenience I am writing VIBGYOR. It is an example of a continuous spectrum. I am repeating. This is a source of white light. From this white light is generated and passed through the prism. After the passing through the prism, it will be dispersed into 7 colors and they are arranged in the increasing order of their wavelength. Here lambda will be so small, here lambda is so large. This is called continuous spectrum. There are no gaps. To explain this absorption and emission spectrum, this basic information is required. Come to the same source of white light from the same substance passed through a sample of gases containing hydrogen atoms. Here this gas is passed through a sample of gaseous hydrogen atom and then passed through prism. Here we are allowed directly without passing through any substance. We are allowed through the prism. Here we are passing the same source, same white light from the same source through the sample of gaseous hydrogen atoms and then allowed through the prism. Then here it undergoes dispersion and they arrange like this. Right? Catch the difference? For explaining the absorption and emission spectrum, I am taking white light from the source and it is subjected to dispersion by passing through the prism, and I am getting this type of spectrum. Same light now I am passing through the prism. Before entering into the prism, this gas will travel through a source sample of gaseous hydrogen atom and then subjected to dispersion. Here student have to remember, this white light when passed through this sample of gaseous hydrogen atom, some of the radiation is absorbed by this sample. Some of the radiation is absorbed by that hydrogen gaseous atoms to undergo excitation for their electrons. So for the convenience I am writing there are two colors, two radiations are observed by this one. What are those two radiations observed by that sample of hydrogen gas? For the sake of convenience I am giving indigo, green, orange, suppose ego, okay, indigo, green, orange. No need to fix this radiation. For the better understanding of the absorption and emission spectrum only, I am taking the white light to explain the concept. It is not practical, it has no practical evidence. This hydrogen sample will take the indigo, green and orange and the remaining colors will pass it through the prism. No, for better understanding only I am taking like that, right? And what are the colors will traveled? And this radiation is called transmitted radiation. This is called transmitted radiation, right? Now this transmitted radiation has how many colors? Among the VIBGYOR, violet is left, indigo there, and blue is there, green is absorbed by the hydrogen gas, and yellow is there, orange absorbed by the sample of hydrogen atoms, and red is there. So now you have four colors. If it is dispersed, you are getting four colors. Now you are advised to compare. Violet color is there or not? In this spectrum, violet color is there. Here also violet color is there. This spot is called, suppose, violet. This is violet color. So write violet. Indigo, there is no space, there is no color here, because that indigo absorbed by the sample of gaseous hydrogen atoms. You left the space. And then blue color is there. Blue color. And then green is absorbed by the again hydrogen gases. And this is yellow. And orange is absorbed by the sample of hydrogen gas. So this spot is called red. So these three areas are in the photographic plate appeared in dark color, appeared as a dark spaces because photographic plate is black in color, so it is a dark space, dark in color, right? This spectrum is a discontinuous spectrum. Here all colors are continuously present. Here these are separated by some gaps. So it is a discontinuous spectrum. This is discontinuous spectrum. Understand? Here this spectrum is obtained by the analysis of the transmitted radiation. Such a spectrum is called absorption spectrum. It is not the meaning absorption spectrums are discontinuous or discontinuous spectrums are absorption. There is no relation there is no correlation between absorption and discontinuation. The spectrum which is obtained by the analysis of the transmitted radiation is called absorption spectrum, or the spectrum in which all the radiations are not be present in a serial order, then that is called a discontinuous spectrum, or these radiations are separated by the gaps called discontinuous spectrum. This is the explanation about the absorption spectrum. And students, let's see, now we have a sample of hydrogen gas, right? That is hydrogen atoms or hydrogen molecules. We have hydrogen atoms. These hydrogen gaseous atoms, electrons are in the excited state because they have the energy, excited state. If this hydrogen gas sample is heated now, they will be excited again, and in the excited state they are very unstable. They release their energy in the form of light. Simply, this sample of hydrogen gas, when heated, it releases its absorbed energy in the form of light. That light is called emitted radiation. Emitted radiation. If you analyze, if you are passing that emitted radiation through the prism, it disperses into its component colors. What are the component colors? Here you have one color. What is the color? That is indigo, and there is a space, and then green, and then orange. So these areas are bright in color, the remaining areas are dark in color because photographic plate is a black in color, right? So this area is dark, this area is also dark, this area is also dark, this area is also dark, right? So this is also example for a discontinuous spectrum. This is also example for discontinuous because all the spectral lines, all the radiations are not in touch, they are separated by gaps. Discontinuous spectrum, right? Here, this is the spectrum obtained by the analysis of the emitted radiation. So this can be called it as emission spectrum. Emission spectrum. Look at this. This is a absorption spectrum. This is an emission spectrum. How they formed? It is formed by the analysis of the transmitted radiation. This is obtained by the analysis of the emitted radiation. If you are placing these two one above the other, you are getting this spectrum. Understood? And these two absorption and emission spectrums both are complementary to each other. Both are complementary to each other. What is meant by complementary? Complementary to each other. Very simple. If you join these two spectrums one above the other, you are getting this spectrum. Or in another words, here if bright lines are there in the absorption spectrum, exactly at that area dark lines are there. If here dark lines are there, then here bright lines are there. That means one area is dark in one spectrum, exactly in such a area of wavelength bright lines are there in the another spectrum. So that's why they can be called it as a complementary. They can be called it as a complementary. Right, students? This is about the absorption and emission spectrum. For this also we will look at the some printed information regarding the absorption and emission spectrum by the photographs. Now this is final part of the simple explanation of the spectrums. What is the line and band spectrum? Line and band spectrums are also called as atomic and molecular spectrums. Why they are called atomic and molecular spectrums? The simple reason is line spectrum is formed by the atoms, band spectrums are given by the molecular spectrums, molecules. That's why they are called, line spectrum is also called atomic spectrum and band spectrum is also called molecular spectrum. Before to explain what is line and band spectrums, we are taking an example of hydrogen atoms. If hydrogen atoms only H is there, these are called atoms. H2 molecules are there, these are called elements, and this is a molecule. This is a molecule. In the hydrogen atom, when you supply energy, that energy is utilized generally for electron excitation. Electron excitation. If you supply energy to this H2 molecule, here the supplied energy is utilized for electronic excitation and vibrational, rotational, energies. In case of water molecule or in case of molecules also. That means here energy absorbed or released is associated with only for electronic excitation. Here for the diatomic or polyatomic molecules, the absorbed energy may utilized for electronic excitation and vibration of the substance or rotational energies like that, right? Because if you take the hydrogen and hydrogen, this hydrogen can rotate, this hydrogen can rotate, for this also energy is required. If you take the HO and OH, suppose you can be considered it as one part and it can be this hydrogen is a hanging part, it may vibrate from here to here, right? It may vibrate from here to here, so it also requires some energy. So in case of atoms, the absorbed energy is only associated with the excitation. Here it may do some other works. If these substances are heated, it releases the energies or the radiations of having the only one or two types of wavelength, short range of wavelengths. Short range of wavelength, right? When you heat these substances, they release the energy with long range of wavelength, long range of wavelength, right? Short range of wavelength means, suppose it is varying its wavelength from 100 to 105 nanometer, then you are getting that spectral line like this, right? If it is made up of different types of electronic transitions and the vibrational rotational changes, it is a cumulative of all these radiations, so it may release as a long range wavelength. If you are taking the photographic plate, they collectively appeared as some band. It is a combination of different wavelengths, so it is appeared as a band, it is appeared as a line. So that's why it is called line spectrum. It is called band spectrum. This is a line spectrum and this is a band spectrum. In line spectrum given by the atoms, so it is called atomic spectrum. Band spectrum given by the molecules or elements, so it is called molecular spectrum, right? In case of line spectrum, distinct lines will be appear in the on the photographic plate. Distinct lines. This is called a line spectrum. In case of band spectrum, the spectral lines are appeared as patches or appeared as bands with small gaps. Right? This is line spectrum, this is called band spectrum. This is brief explanation about the line and band spectrum. Right students, thank you for watching my videos, and please subscribe and share to your circle.